Hi there, and welcome to an update on a few geologic events that have taken place in Iceland over the past few days. I'm Geology Professor Shawn Willsey. Thanks for joining me. Thanks for spending a little bit of time here. Appreciate your support of the channel, whether that's just with great comments, financial, or otherwise. It helps us put together more of these geology education videos. Today is Tuesday, July 30th. It's about 2 p.m. here in Idaho, about 8 p.m. over in Iceland. And let's get right to the update. What we'll do first is summarize some of the latest happenings and data on the Reykjanes Peninsula, and then we'll look at what happened over the weekend with Katla, another volcano in the central portion of Iceland. So let's start with the Met Office update. And a new one just came out today, so this is quite timely. So increased probability of a dike propagation and a volcanic eruption in the coming days. So again, we're as the days go by, we're getting closer and closer to the next event where this magma that's stored in the subsurface beneath the power plant area, something's got to happen with it. It's got to move somewhere. It's going to have to come to some sort of a head one way or another. So number of earthquakes per day is steadily increasing. I'll show you more with that here in a minute. Model calculations suggest enough magma has now been recharged to the Svartsengi reservoir to trigger a new event. So again, we have sufficient magma volume in the subsurface to trigger or cause an intrusion or an eruption. And likelihood that this will occur within the next 7 to 10 days. So the next week or so is going to be critical. And of course, no one knows exactly when that's going to happen, but we're kind of pegged to the data that we're getting and trying to figure out exactly when that window might open up and exactly where that might take place. Excuse me. Geodetic measurements show that the rate of uplift has decreased slightly during the past few days. This, along with the type of seismicity that was detected yesterday, are indicators that a dike propagation or a volcanic eruption may be imminent, and the hazard map is pretty much the same as it was last week. So yesterday there was lots of small earthquakes in the area. I'll show you those here in a second. The activity lasts about 50 minutes and suggests that pressure within the system is increasing. Over the past 2 weeks, the number of earthquakes per day has been increasing. This is what we expect to see, right? Once the magma's filled all or most of the available space, and it starts putting pressure on weak points in the system, fractures, weak zones, that magma is going to have to break rocks in the subsurface, and that's what's going to trigger these small little earthquakes that have been happening. So we talked about the model calculations and likelihood of the next 7 to 10 days. And then we have our same hazard map. Remember, too, that when we looked at this in my last update, the Met Office is calling out 2 possible scenarios. Let me just switch over here to our good old Google Earth view. So here's where the last eruption was, more or less, at least the last spatter cone that lasted the longest. Here's the lava field from that. Let's go ahead and get rid of that, though, for a second here and just kind of look at a fresh map. We'll leave the defensive berms in. So essentially what we're looking for is 2 possibilities. Probably the most likely probability and scenario would be an eruption up near where these 4 eruptions took place. The December, February, March, and May eruptions were all in this same region right here, more or less east of the power plant region. And that's where we expect the next eruption to take place. That's, I think, has the highest probability of an eruption here. And the Met Office's scenario calls out like exactly, how long that might take those lavas to reach the defensive berms around the power plant and also the town. And so that's one scenario. And we've seen that before, right? So if that scenario comes to fruition, we know what that should look like because we've seen several iterations of that over the past few months. The second scenario, and probably the one that's the most concerning, although it has a lower probability of happening, is something further south. And there's some big fractures near this hill and in this hill, Hagafelt. And of course, we had the January 14th eruption in this region right here. And so the second scenario calls for the volcanic vents to open up somewhere in the region of this hill, southeast of the power plant, north of the town, or possibly behind the defensive berms, which is a possibility because, again, we saw that January 14th with this small fissure, short-lived fissure, but it did take out 3 houses before all was said and done. So that one, of course, would produce lava flows that reach infrastructure in the town much more quickly. So those are the two scenarios that they're looking at right now. Let's go look at some of the data itself now that we've kind of read through the Met Office update. Oh, and by the way, there's this new, I'll make sure this is in the video description. I haven't played with this a ton, but it looks like it'll be helpful moving forward. This is another website put together by the Met Office, and you can add and subtract lots of things here. So the blue pins are all GPS stations, and you can click on any one of these and access and look at the GPS data for that station. So here's a station here, and the three graphs that go with the ground deformation or the GPS data over the past, looks like 3 months, but you can change that as well. You can do a 1 year, you can change it to other time frames. So that's helpful there. Then you can see lots of lines on this map. Let me kind of stop moving a little bit there for you. And then if you come up here to the right, you can see what those actually mean. So for example, I can add in or take out, I suppose, the fissures, which are these yellow lines. So those are either tectonic or volcanic fissures, not quite sure. They look like they're probably more tectonic to me just looking at their location. Let's see what else. Lava fields that are in here, you can take out some of those. So there's like the Fagradalsfjall lava fields there. Anyway, lots of different geologic data here that you can take out or throw in. If you don't like the base map and you want more of the satellite image, you can add that in as well. So that's a nice little handy, another tool we have in our arsenal as we look at and discuss some of the things happening in Iceland. So I just want to make you aware of that. So looking at earthquakes over the past, just the past 24 hours, there is a few more. I mean, just, me jumping in and doing these updates every 3 to 5 days or so. It looks like there, and this is what the Met Office update also alluded to as well, there's more earthquakes happening in this region than we've had in the past. Again, that's to be expected now that we're kind of reaching that critical threshold where the magma body is. A little cluster here around to the north or northwest of Grindavik near Thorpjord, the hill that sits here. Again, nothing in and of itself that's alarming. Looks like the biggest one there is a 1.7 that occurred today, but again, pretty deep. The whole area is under stress, right? So we've got this magma body that's filled in the subsurface. So rocks and fractures in the immediate region are going to feel the effects of that continual influx of magma, and that might cause them to fail, shift, move, and those will of course generate earthquakes. But you can see some of the earthquakes here along this the main Sunnukur lineament here. But again, mostly small earthquakes, nothing right now that says an eruption is about to take place. But this would be this would be a place I would look at at least once a day, maybe more often, depending on how closely you want to monitor this thing, and looking for any sort of noticeable uptick in these quakes, especially over time and space. That might be a good indicator that the magma is moving into the subsurface and an eruption may be possible. Looking at the past week or so, we'll get to these earthquakes down here. That's the Katla earthquakes from this past weekend, or I guess yesterday and Sunday. But looking at the area around Grindavik, you can see the colors there, a lot of oranges and reds, so those are fairly recent earthquakes. So there is something definitive about the data, and a little bit more recent upswing in earthquake activity, at least over the last couple days. Again, nothing in and of itself that suggests that an eruption is likely to take place anytime soon. I'd expect to see a much more dense concentration of these earthquakes in order for that to be the case. And while we're on the topic of earthquakes, let's switch over to our good friend and viewer Bruce Garner sent me an email, and he's been looking at the data and the earthquakes as well. And one graph in particular he sent I thought was pretty insightful. So here he has plotted up excuse me, the number of earthquakes per day in this region going all the way back to March. Okay, so there's March 16th, which was the beginning of one earthquake. Then you can see the earthquakes drop off quite low for the most part because the eruption was ongoing through April. But then here they start building back up and reaching ahead on May 29th. So the biggest spike there is the the beginning of the last eruption, which was on May 29th, then you can see them dropping back down. But what you can see here overall, crudely, there's some spikes here and there, but there's definitely a building of the total number of earthquakes for the most part leading up to the day of the eruption. There's a little bit of a lull here, the quiet before the storm, I suppose you could say. That's not something I would guess that shows up every single time, but at least with this last eruption, you can see a general build in total number of earthquakes. And then if you look at where we are now, here we are at the end of July, we are definitely, looks like there's definitely been an upswing in total numbers of earthquakes. So let me squeeze my little head down a little bit. There you go. Now you can see that bottom right corner better. Sorry. So here we are, July 29th, 30th, right here at the very far right end of the graph. And you can see over the past few weeks, there has been an upswing overall in the total number of earthquakes. And if you look at kind of the cumulative amount of earthquakes here, where we are today, that kind of crudely matches maybe this kind of region in here around the end of April, early May. And again, just if we're looking at the last eruption and its precursor activity as a predictor of the next eruption, which I'm not saying we should do, but if we just do it as a thought exercise, that would seem to indicate we probably have another 3 or 4 weeks before we get to the eruption. And so maybe we're further away than we think we are. Then again, all this could escalate quite quickly. So, and this is just one lead up. But thanks to Bruce for putting that together. I thought that was pretty insightful. The other thing he had, so he has a model where, let's see, here we go. He takes, so this goes all the way back to last year, October. This is the GPS data for this specific station, and looking at the height of the GPS station. So it's gone up and down. It's gone down when there's been an eruption or an intrusion. It's gone up as more magma has accumulated in the subsurface and there's been inflation. And you can see this takes us up to about right here is where the data ends, because that's July 29th, 30th. That's today. And so if you look at just the rate of uplift here, which is over here on this right axis, millimeters per day, the rate at which the ground is rising per day pretty closely matches, if you look at this green line, which is the average rate for the last eruptive period from April leading up to the May 29th eruption. We're kind of right at that number right there, about 4 millimeters per day of uplift at this station. And so by using that, he does some cool gee whiz extrapolation and modeling and calculations to figure out when that next eruption might take place. And it all depends on what that critical zone is. How high can the ground rise before the pressure in the subsurface is such that that causes the magma to reach the surface. And it looks like he's got the window kind of in late August, maybe into early September. So he has us maybe about 3 to 4 weeks out from any sort of event happening. Again, these are just models and forecasts. Nothing hard about these, nothing definitive about these, but just a fun way for us to kind of pass the time and speculate a bit while we're in between these eruptive phases. So thank you again to Bruce Garner. Appreciate when you send those, and thanks for letting me share those as well with folks. Let's look at the GPS data, which we did sort of see a bit there. We'll go to the Svartsengi station, but they've recalibrated the axes here, and so added bigger numbers here in terms of uplift. So these look not quite as impressive as they have previously, but nonetheless you can see the uplift continues, right? This trend continues to march upwards. If we go to a different station that might show us a little bit more insight here, let's go to, we can go to this one here, Thorpjord. You can see the uplift going on. There was a little gap when there was a little glitch in the data being relayed, and then the uplift continuing here. So we've been at pretty strong, fairly linear trend with not much of a deviation in slope there, I'd say, over the past couple weeks. So if that continues for the next week or two, who knows how high that will get before we get some sort of eruptive event. Moving on to some of the news stories that was sent to me by Amanda Jo, and appreciate her as always for helping me compile these updates, getting all the information together. Very helpful, saves me a lot of time. So shout out to her as always for her help. This was a fun one here. There's a company that put together a 3D imagery or model, I suppose, of the most recent lava flow, or maybe this is an aggregate. I'm not quite sure. Maybe an aggregate of all the lava flows there. You can read through and see if which one is true there. But you can see the lava deflected around the berms here in the town where the spatter cone is. It's higher. This looks like it's, of course, exaggerated vertically to kind of make it pop in 3D because the lava is not exceptionally thick in many places. So so they've amplified its vertical dimension in order to make it look a little bit more kind of eye-catching or impressive. But they've been able to model the volume of the lava at about, the area is about 13.6 square kilometers, and the volumes are around 150 million cubic meters. So quite a bit of lava that has come out of the ground there north of town since last December. So very cool stuff, cool technology, and a great way to use that to help us acquire more data. So let's turn now to the event that took place at Katla. And so I was gone when a lot of this took place on my river trip. So I'm getting this information through the news Amanda Jo sent me in somewhat second, third hand. But as many of you know, further to the east in Iceland, there are bigger volcanoes, what we call central volcanoes, much more explosive types of volcanoes, different magma chemistries. But thankfully, they don't operate and erupt on as frequent of a basis as kind of what we're seeing over here on the Reykjanes Peninsula. But nonetheless, there's a volcano that sits underneath this glacier here called Katla, and it's probably one of the two most dangerous and impactful volcanoes in Iceland. And there was a glacial outburst flood that occurred on Saturday, July 27th. And so part of the ice melted quickly. That flowed downhill through these various channels here. And in one particular river channel here, there was some damage to the ring road. This is the primary road, Route 1, that takes folks around the island. That road was damaged, but bridge wasn't washed out, and the road was closed for some time along this section, so folks couldn't drive through. That since, though, has been the floodwaters have subsided since then. They are letting cars through, I think kind of like one direction at a time was the last thing I heard so far. And the alert level briefly was raised to yellow, so from green to yellow when there was a little bit of uncertainty about where this might actually go. So there's an article, and I'll put all these in the video description there. You can see a photo of the road actually going over the bridge. I'll show you a video here in a second, another video or photo there as well. And they've moved the aviation code to yellow just as a precaution. Not sure if there was going to be something that the volcano might do that might impede or impair air traffic in the region. So, and you can see all the flooding across the roadway there along this river. It's called the Skalm River. Let's see what else. So here's a quick little video that shows the event taking place over the roadway. So there's the bridge and the roadway and the water coming across. Of course, with this kind of power, you get debris in here that can damage the bridge pillars and other things that can sometimes take the bridge out. Thankfully, that didn't happen in this case, so the bridge was able to be put back to use pretty quickly. Unfortunately, Amanda Jo did find this here. Apparently, there was a big farm nearby and a lot of sheep in the area, and they're not sure yet until they can kind of, get all the sheep together, gather all the sheep and count them, but there's a possible chance that some of the sheep might have been swept away in this glacial outburst event. It doesn't appear, based on the Met Office's analysis and some of the things I've read, though, that this was caused by a volcanic eruption. So what we think might have happened is that some of the hydrothermal, the hot groundwater beneath the glacier in the shallow subsurface, that might have actually been the cause of the melting of the glacier, the release of the water from the base of the glacier, as well as the earthquakes that took place there, because there was a little flurry of earthquakes, mostly 2.9, I think, is the biggest one in there. Yeah, 2.9 and under. And then most of this came down this drainage over here to the east. But none of this, as far as we can tell so far, and this has been, more or less agreed upon by several folks closer to the scene, scientists, that this was not a subglacial volcanic eruption, but just probably something in the hydrothermal system, earthquakes, and other activity that triggered the release of some of that meltwater. So anyway, so it's good news moving forward, but definitely a volcano that we continue to monitor and watch, Katla, along with many of the other volcanoes in Iceland. So that's it for today. We'll keep track of this activity going on the Reykjanes Peninsula, as well as anything else that might be going on in Iceland, and put together another update for you soon, possibly this week. We're kind of heading into this window where things might ramp up and escalate quite quickly. If that's the case, I will do my best to get you updates and information as quickly as possible. But for now, I suppose watching the seismic data would be wise, taking a look at the GPS data from time to time, and as we get really close, maybe even watching some of those webcams as well, and seeing, maybe catching the first phase of the eruption commencing. So thanks again for your support and your time. Hopefully this update was helpful to you, and we'll see you next time. Take care.